we present to your attention a unique wastewater and industrial water treatment plant. The plant, with a capacity of 5 cubic meters per hour, is capable of cleaning and disposing of a wide range and high concentrations of pollutants, including filtrate and filtrate concentrate of waste management facilities, oily wastewater and industrial waters, hypertoxic effluents of industrial enterprises. The uniqueness of the equipment used in this installation makes it possible to purify contaminated water to meet the maximum permissible concentrations, allowing the water that has been processed to be diverted to fissures reservoirs. The installation consists of the following equipment: mechanical lower type filters with a pore diameter of 250 microns, electrochemical cleaning zone, an electrochemical synthesis and destruction zone consisting of 3 consecutive reactors, mechanical lower type filters with a pore size of 25 microns, aeration unit with ozonation, bulk sand filters, filtration unit with metal ceramic filters, installation of microcapillary filtration and superfiltration, composite sorption unit. The filtrate of municipal solid waste landfills and filtrate of municipal solid waste processing complex, with the help of a specialized vehicle, is transported from the object of education to the storage tank, which is located on the territory of the filtrate cleaning, disposal and neutralization complex. With the help of pumps and pipelines, the filtrate from the storage tank is fed to the installation. At the first stage, the amount of large mechanical impurities in the filtrate is reduced. For this purpose, mechanical louver-type filters with a pore diameter of 250 microns are used. After that, the filtrate enters the electrochemical purification zone. In the first reactor, the filtrate is exposed to the electrocoagulation process using consumable electrodes made of aluminium and stainless steel. As a result of the electrolysis reaction, poorly soluble aluminium hydroxides are formed, which coagulate impurities, enlarging colloidal particles as a result of their adhesion, resulting in their flocculation and adsorbing already coagulated particles. Then the filtrate enters the zone of electrochemical synthesis and destruction. These are 3 consecutive reactors using non-consumable electrodes, on which a number of substances are synthesized that are responsible for the purification process and enter into active redox reactions. In the process of electrochemical synthesis and destruction, metals are either oxidized to the oxides and salts or reduced to pure inactive compacted crystals. Organic substances undergo degradation with the formation of atmospheric gases. The presence of an extremely high fragrancy generation increases the rate of oxidation of organic and inorganic substances. The foam formed on the surface of the filtrate is sent through a pipeline to the waste storage tank using impeller pumps. After the electrochemical purification and destruction zones, the filtrate enters the mechanical filters of lower type with a pore size of 25 microns, designed to cut off mechanical impurities. Then the filtrate is sent to the aeration unit with ozonation, where there is a further reduction in biochemical and chemical oxygen consumption, oxidation of organic impurities, bacteria and viruses, reduction of color, elimination of odor and chlorine-containing aromatic compounds. After this block, the filtrate enters bulk sand filters designed to remove fine suspensions from the water. Next, the filter is fed to a block with metal ceramic filters to remove residual suspended solids and reduce turbidity. The pre-purified filtrate accumulates in the averaging tank and then enters the macrocapillary filtration and superfiltration unit. In the macrocapillary filtration module, the residual content of suspended substances is removed, including the removal of turbidity, partially color, odor, and almost all colloidal particles and microbiological contaminants are also filtered out. In the superfiltration module, dissolved salts in ionic form toxins, including tetrodotoxins, are removed. The final removal of homogeneous particles and molecules takes place, which allows large charged particles to be almost completely removed from the water. The membranes of both modules are flushed with permanent, purified water without the addition of chemicals. At the final stage, the filtrate is fed into the composite sorption unit, where the final purification and pH averaging takes place, and possible humic and fulvic acid residues are removed. The result of the process of processing, neutralization and disposal of the filtrate is water containing the maximum permissible concentrations of pollutions that allow this water to be diverted to water bodies for fishery purposes. The distinctive features of the technology used in this technological solution are energy efficient, low waste, best available technology for the treatment and disposal of wastewater and industrial waters of various industries. The technological process takes place without the use of any reagents. The installation is automated and does not require the constant presence of personnel. High performance of purified water, more than 95%. Absence of waste in the process of pollution processing. The ability to increase power by simply connecting modules. Due to the design solution, the operating costs of the installation are the lowest compared to other installations and stations for the treatment of contaminated wastewater.